Hey there, I'm Brett and welcome back to Math Hacks. Today we are going to be using the factor theorem, the rational zeros theorem, and synthetic division to find all the rational roots of a polynomial. So how our problems are going to work today is we are going to be given a polynomial equation and asked to find all of its rational solutions. And we are going to look for the solutions by using the rational zeros theorem and the factor theorem. And that's because we want to find the solutions by hand. If we were to find the solutions by graphing, we would simply graph the equation and look for the places where our graph crosses the x-axis. Now, when we're finding them by hand, we have to do a little bit more work. The first thing we need to know is what our possible solutions are. And that's where the rational zeros theorem comes in handy. It says that any potential solutions can be found in a list that we can generate by taking all of the factors of the constant in our polynomial and dividing it by all the factors of the leading coefficient. Then we'll take all of those potential solutions and we will test them by using synthetic division, which is the technique we talked about in the last lesson. We will know which solutions are true solutions because they will have a remainder of 0. Now that I've thoroughly confused you with all of this math talk, let's jump into some problems and see if we can digest some of what I just told you. So in our first problem, we are asked to find all rational roots of the polynomial x cubed minus 2x squared minus 2x minus 3. So essentially they're asking us to find all the places where this function, this polynomial equation here, crosses the x-axis. In other words, it's where the y value equals 0. So another way you'll see this is just as solving the equation set equal to 0. In today's lesson, we're going to be using the rational zeros theorem. Our rational zeros theorem says that all of the rational solutions will come from this list that I'm going to make by taking the factors of 3 and dividing by the factors of 1, since x cubed is the same as 1x cubed. So I'm just going to write it like this to get started. So the factors of 3 are plus or minus 1 times plus or minus 3. And the factors of 1 are plus and minus 1. Now I'm going to list out all the combinations I can make by dividing plus and minus 1 and plus and minus 3 by plus and minus 1. These are the values I'm going to test to see if they're a solution. And how we're going to test them is by using synthetic division. And I talked about synthetic division in one of our previous lessons. So if you need a recap of how that works, you can check out that lesson. How I know that one of these potential solutions is a solution is when I divide it using synthetic division, I want the remainder to equal 0. So I want r to equal 0. If it equals 0, then we know that's a solution. I like to start with just the easiest numbers, so I usually start with positive 1. Remember that in synthetic division, these numbers come from the coefficients on our polynomial that we are dividing. And if you are skipping over any power here, this one doesn't have any power skipped. But if it did, I would place a 0 to hold its spot. I think in our next example, we'll have one where we skip over a number and you'll see exactly what I'm talking about. So I'm just going to go ahead and synthetically divide with 1 to see if my remainder equals 0. So this one doesn't turn out because r equals negative 6. Let's go ahead and try the next one on our list, negative 1. So this one doesn't work either since r equals negative 4. There we go, we found one that works. So that means that x equals 3 is a solution. So we've found our first solution. Now, because this is a cubic, I can have up to 3 solutions. So I keep wanting to work with my resulting polynomial here. And I just went ahead and rewrote these as the coefficients, and I started with 1 degree less than the equation I was dividing. So that means that this was a cubic, so I know that the answer here will be a quadratic, or a power of 2. Now I have a couple options to solve this equation. I can either do the rational zeros theorem again on it and synthetically divide out the potential solutions looking for one that works. Or I can, since it's a quadratic, I can factor it, or I can use the quadratic formula. I'm not seeing any obvious ways to factor this, so I'm just going to make sure that there are no other solutions by using the quadratic formula. Now, because I have a negative number under my square root, I automatically know that this polynomial here has no real solutions, which means that the only real solution to our original cubic equation is x equals 3. So that just means that in our graph, we have a cubic function that only crosses the x-axis in one place, and that's perfectly fine. Remember, you can have up to the degree, but not necessarily always equal to the degree. In our next problem, we are going to try to find all of the rational roots to the equation 4x cubed minus 7x plus 3. So once again, I'm going to begin by using my rational zeros theorem to make a list of all the potential zeros that could be solutions to this equation. So what I did here is I just, in the numerator, placed all the factors of my constant. So that's all the factors of 3. And then I divided by all the factors of our leading coefficient. The leading coefficient in this case is 4, and my factors for 4 I know is 1 times 4, positive or negative, and 2 times 2, positive or negative. Next, I'm going to take the ratios of all of these. So I'm going to divide plus and minus 1 by plus and minus 1, plus and minus 4, and plus and minus 2 to list out those possible solutions. And then I'm going to take plus and minus 3 and do the same thing. I'm going to divide it by plus and minus 1, plus and minus 4, and plus and minus 2. So that's going to make a long list of potential solutions, and sometimes that just happens with these problems. So here are all of the potential solutions that I can check to see which are actual solutions to our polynomial. I'll use synthetic division to test them, starting with positive 1. Now notice in this equation, as I was mentioning before, sometimes you have polynomials where one of the powers of x is skipped. See here how I have an x cubed term and an x term, but I'm missing an x squared term. So be very careful here to place a 0 for the x squared term when you go to divide. So even though it doesn't show up here, you still need to write a coefficient for it. All right, we got lucky this time, and the first one we found has a remainder of 0. So this is a solution. That means that x equals 1 is our first solution to our polynomial. And I have a new polynomial here to work with. Remember, my new polynomial is always 1 power less than our original that we divided. So this was a cubic. That means this one will be 4x squared to start, plus 4x minus 3. And again, this can be set equal to 0 because we are looking for solutions of x. Now, again, here I have a couple options. I can do the whole rational zeros theorem and synthetically divide out each one until I find one that works. Or because this is a quadratic, I can go ahead and factor or use the quadratic formula. This one I'm going to choose to factor, and it looks a little bit tricky because we have an a value that's greater than 1. But remember, the easiest way to factor a quadratic where a is greater than 1 is to use the ACB method. Again, this is equal to 0. And remember that when we have two things multiplied together set equal to 0, I can go ahead and say 2x plus 3 then equals 0, or 2x minus 1 equals 0. Solving each of these equations, I get x equals negative 3/2 because I'm going to subtract 3 and then divide by 2. And here I'll add 1 and divide by 2 to get x equals 1/2. So those are the other two solutions to my polynomial. So my solutions are x equals 1, x equals negative 3/2, and x equals 1/2. So those are the three locations where my polynomial will cross the x-axis. If you enjoyed today's lesson and would like to see more tutorials, there are two really easy things you can do. 1, click that subscribe button if you haven't already and join our community. 2, give this video a big thumbs up to recommend. Till next time, I'm Brett, and thank you so much for watching.